Okay, in this video, I'd like to show you some common metamorphic rocks that are found throughout the world. If you remember, metamorphic rocks are another rock type that was subjected to heat and or pressure and or fluids, complex fluids flowing through the pore spaces in the rock. Another important component is time. The longer they're exposed to one or more of these conditions, the more the rock can change and larger perhaps crystals can get. One of the key things when we talk about metamorphic rocks is the idea of them under pressure. And pressure comes in two forms. You can either have uniform pressure or you can have differential pressure. Uniform pressure is just the fact that it's buried in the earth. And differential pressure is where you have tectonic forces perhaps pushing against a continent and forming what we call foliation, or lining up the crystals in neat ways. So foliation, the foliated rocks are shown over here, and the non-foliated rocks that undergo just uniform pressure are shown over here. We only have one example in your lab, which we'll call marble. But let's talk a little bit about metamorphic grade through the foliated rocks. We go from a little bit of foliation, like slate, and it goes through various levels. The more time it's spent, the more uniform pressure is on it. So slate, you put under time and pressure for a longer time, it starts forming rocks we call phyllite. If phyllite is then put under more time and pressure, it'll turn into a schist, and schists finally go to, well, the last one we're showing you here is a gneiss. For the foliated rocks, the basic identification features you use is you look at the foliation patterns. For slate, it's very flat. It's called slaty cleavage. So basically, it breaks off, and if you thump it, it kind of rings. For phyllite, new minerals will start forming. You notice this has got a nice green sheen. That's chlorite, and it starts getting wavier. So it's kind of got a wavy pattern inside of the foliated marks. Schist, it becomes even more wavier, and some new minerals start forming. You see a lot more mica in this, and if you look at it very closely, you start seeing big wavy patterns, but it's no longer continuous waves, and minerals are starting to separate out. New minerals start forming like garnets, and on the back of this you see these bubbly marks. That is garnet, a large crystal is called garnet. Here is another mica schist that you see lots of mica in. And then finally, we have the highest grade of metamorphism. This is called gneiss, and in gneiss you can actually start seeing lines or bands of dark and light minerals forming because of the foliation process due to differential pressure. For the non-foliated rocks, the one example we have is marble. Marble is calcium carbonate, and most likely formed from a limestone that was undergo the heat and pressure and fluids, where the calcite crystals were reformed into much larger crystals. And as you move this, you can see light reflecting off the crystal facets.